not for today I'm going to be explaining Newton's laws using Tide Pods.
Alright, so Newton's first law essentially states that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an unbalanced force.
Now, this is taking into account that these objects are in space. If you put a force on an object, it will move in that direction of the force forever. Except on Earth, there's friction, so it slows down over time. You'll see that in the experiment.
Newton's first law is pretty simple. This object is currently at rest. Let's see what happens when you apply a force. You will notice that the object has moved because a force has been acted upon it.
Free body diagram for our experiment. These normal forces and gravitational forces cancel out. If you only had this force right here, the object would continue into space for forever. But because we have the force friction, the object is slowed down over time. Newton's second law explains the relationship between force and an object's mass times acceleration, basically stating that for a larger mass, let's say m1, it requires more force to move m1 than it does to move m2 to achieve the same acceleration. Alright?
You will notice that the smaller mass has traveled farther than the larger mass. This is because it requires less force to move the smaller mass than the larger mass to achieve the same acceleration.
Newton's third law of motion states that for every action, there is an equal but opposite reaction. This can be related to the conservation of energy, in that energy cannot be created or destroyed. Essentially, you have an object, such as a ball, being thrown at the wall. The ball transfers its energy to the wall, and energy is released back again from the wall into the ball and moves in the opposite direction. So energy is not being destroyed in this system, it is simply being transferred.
So we have a Tide Pod. We will apply a force downwards on the Tide Pod, and once it hits the ground, it will create an equal but opposite force upwards.
Cavello, go. Alright, well, you'll notice that the Tide Pod has jumped up a bit, not very much because Cavello's weak, but it's cool.